This represents the Kubernetes architecture. It has two parts. One is the control plane and the other one is the data plane. In the control plane, we have the API server, which exposes APIs to the external world. And Kube API server manages all the API objects that represents each of the resources. Kube controller manager has a bunch of controllers. The responsibility of the controller is to bring the status of each of the resources to its desired state. Then we have the Kube scheduler. It will assign any unassigned port to a node. HCD server is used to store all the configurations, and Cloud Controller Manager is used to connect to any of the cloud provider APIs. In the data plane, we have the kubelet in each of the worker nodes, and this kubelet will replicate any instructions from the API server. That means if there is a pod object created in the API server, then kubelet will deploy that pod object in the worker node. And a kube proxy will create the network rules. Let us see how these components work together with an example. In this representation, we can see that there's a control plane which is having an API server and the data plane which is having two worker nodes. Worker node 1 is having the kubelet 1 and worker node 2 has kubelet 2 as the node agent. To represent each of the worker node, API server has the API node object. Now, one of the user apply a deployment.yaml file. In this deployment YAML file, it says to create 3 ports for one of the image. So once API server receives this instruction, it will go and create a deployment API object with the name kubestudy. Here in the manifest file, the name of the deployment is mentioned as kubestudy. Here there is a new resource created. That information will be stored into the HCD server. And every change will be stored into the HCD server for every resource. Now, deployment controller will come into picture. Here, deployment controller will check for new or updated deployment object. And it will find one because there's a deployment API object created newly. That's the kubestudy. Deployment controller will instruct API server to create ports for kubestudy. So 3 ports need to be created and API server will start creating the ports. Now we can see that these pod objects are created, but these pod objects are not assigned to any of the worker node objects. Kube scheduler will be continuously checking the API server for any unassigned ports. And now it will find 3 ports, port 1, port 2 and port 3. So Kube scheduler will do a filtering and scoring on the nodes and assign ports to the nodes. Port 1 will be assigned to worker node 1, port 2 will be assigned to worker node 1 and port 3 is assigned to worker node 2. Kubelet will check for changed configuration for the node. It will find that in worker node 1, port 1 and port 2 are newly created. So kubelet 1 will go ahead and create these ports in worker node 1. That means it will deploy 2 ports in worker node 1. Same way, kubelet 2 check for the changes and it will find that port 3 is assigned to worker node 2. So kubelet 2 will deploy an application in worker node 2. So that will be the port 3. This will give you an idea on how each of the components work together in Kubernetes.